Penicillins are important class of natural product which fall in the category of antibiotics. Basically, antibiotics are those chemical or biological agents which are used to kill or eliminate or inhibit the growth of bacteria. The history, discovery, and synthesis of penicillins are important breakthroughs in the history of organic chemistry. But before addressing these aspects with respect to ultimate synthesis of penicillin, we will focus briefly on the structural feature of penicillin, that what exactly it consists of. Basically, penicillin consists of two membering system. One is four membering system, which is fused with the five membering system. Here we have carboxyl group, two methyl group are attached right over here, and a side chain where we have alkyl group. So this is a basic structural feature of penicillin. The four membering system is known as beta lactam, usually cyclic amides are known as lactams, and a five membering system which is known as thiazolidine. This carbon atom is alpha and this is beta carbon atom. As nitrogen is linked on beta carbon atom, so that's why we call it a beta lactam. As we have stated that penicillin reflects a class of compounds which are differ by the nature of alkyl group. For example, if we change this alkyl group, then we will get a different derivative of penicillins or different penicillins. For example, we have 6 naturally occurring penicillins which are strong monobasic acids. For example, we have a nitrogen and carboxyl group which incorporate both the role of acid and bases in the structure of penicillin. If we have alkyl group like this, which is benzyl, then penicillin will known as a penicillin G. If the alkyl group is some phenoxyether moiety, then we will call it penicillin V. This is penicillin G and this is penicillin V. Similarly, we can change the alkyl group to another benzyl system in which we have an amino functionality. So this penicillin is known as ampicillin. So the nature of alkyl group differ individual penicillin from each other. There are hundreds of derivatives of penicillin that can be made by changing the nature of alkyl group. As far as the biological activity of penicillin is concerned, it is due to beta-lactam, which is unstable. It is not like ordinary amides, where a nitrogen lone pair has the freedom of resonance, and therefore amide are stable. They are less reactive among the derivatives of carboxylic acid. But here, in case of penicillin, the four-member cyclic amide or beta-lactam is not as stable as ordinary amide, because the ring system put a great strain and make it reactive. Therefore, the biological activity of penicillin is linked to a beta-lactam rings. And in fact, all these penicillin are known as beta-lactams because their biological activity is attributed to the beta-lactam ring. Usually, we will come to synthesis later, but as far as the beta-lactam ring is concerned, it prevents the formation of peptidoglycan layer of the cell wall of gram-positive bacteria. It prevents the formation of peptidoglycan, which is sort of enzyme or a layer of the cell wall of gram-positive bacteria. In other words, we can say that it is the beta-lactam ring that neutralize the enzyme needed for synthesis of bacterial cell wall. Once this enzyme is neutralized, then the bacteria will not synthesize its cell wall, therefore it will not continue to multiply, and ultimately it will be exposed to death. So this is how the biological activity of penicillin is linked to the beta-lactam ring. As far as the history of penicillin is concerned, it is quite interesting. Penicillin was first discovered in 1928. Here I am talking about the history. A Scottish bacteriologist Alexander Fleming first discovered the penicillin in 1928 while he was working on his research project, in which he cultured a plate and he inoculated the plate with Staphylococcus bacteria. After a few days, when he returned back to the project, he realized that the growing fold around the plate prevented the multiplication of bacteria, and noticed that a fungus in bread mold had a chemical compound that prevented the multiplication of bacteria of Staphylococci bacteria. So by this way, the penicillin was discovered. Later on, it took many years to isolate the chemical compound discovered by the Fleming. In 1939, an Australian pathologist Howard Florey and a German Ernest Chen finally isolated the chemical compound and named it penicillin. So the history is very interesting and important with respect to ultimate synthesis of penicillin. By 1943, the chemical compound was used for treating the wounds of soldiers were treated with the application with the antibiotics, that is penicillin. And in 1944, penicillin was used for civilian purpose. And in fact, on account of these discoveries, the three scientists shared 1945 Nobel Prize in physiology and medicine. These three scientists were Fleming, Florey, and Chen. All these three shared 1945 Nobel Prize for their discoveries and final isolation of the chemical reagent that was strongly antibiotic in character. During the Second World War, this chemical agent, which was known by the name of penicillin, was seriously required by the United States for treating its soldiers during the war. So it was decided that a synthetic penicillin is need of the time, because the natural penicillin was not sufficient and not enough to fulfill the requirement of the soldier in war. During the Second World War, which took place between 1939 and 45, the US government invested heavily for synthetic production of penicillin. The project was so much extensive that it was comparable to the atomic bomb project, because almost 50 to 100 different labs were engaged, and hundreds and thousands of different scientists, especially organic chemists, were engaged to synthesize the penicillin. Because once the penicillin was discovered in 1928 by Alexander Fleming, for the next 2 or 3 decades until in 1957, when the synthesis was completed successfully by an American John Clark Sheehan. For the next 2 decades after 1928, most of the people, especially soldiers, were dependent on natural penicillin, which was extracted from the fungi. But later, when during the war, the United States and even the Britain government invested heavily to synthesize artificial or synthetic penicillin, but all the project failed during the course of time, and ultimately the project was abandoned because no researchers was capable to synthesize the penicillin. Only one scientist, which I cited right over here, Shinhon, continued his work, and he worked on synthesis of penicillin for almost 9 years until he succeeded in 1957 by announcing the first artificial or total synthesis of penicillin. And in fact, it was him who revolutionized the antibiotics synthetic chemistry. Before Shinhon, after the isolation in 1939 by Australian and German scientists, the next question was related. In 1939, isolation was done, especially the natural penicillin was isolated from the fungi. The next important question was related to the structure, because until the structure is discovered or a molecule is correctly pointed out, no penicillin could be made. So the structure was discovered first before the total synthesis in 1957, and the credit for structural determination went to a Britain female researcher who was not named as Dorothy Hodgkin. Who discovered the structure of penicillin in 1945. So in 1945 the structure of penicillin was discovered by this charismatic British lady who advanced the technique of X-ray crystallography, and in fact it was this technique which she utilized for finding out the correct structure of different biomolecules such as lipid, carbohydrates, even protein, and later on penicillin was also discovered with the help of this X-ray crystallography. So once the structural problem was resolved, then the John Clark, Shinhon, and many other scientists who were engaged by the US and UK government at that time in order to fulfill their war-related requirement of penicillin. So they work on the synthesis of penicillin, but all those scientists and research projects failed except the John Clark Shinhon worked for 9 years, who ultimately succeeded in synthesizing the beta-lactam antibiotic known by the name of penicillin. So this is the important history with respect to penicillin. Let me return back to the female scientist Dorothy Hodgkin. She was awarded the Nobel Prize in 1964 for his tremendous work. So this is all about the penicillin, its brief history, structure, and scientists who played out an important role in the synthesis of penicillin. Basically, Shinhon, let me talk briefly about. He was a US organic chemist. He studied and focused on research project for synthesizing penicillin in MIT, Massachusetts Institute of Technology in US after leaving Merck, a chemical company for synthesizing different chemical, because in Merck he was restricted and unable to take decision. It was only in MIT where he took the power to decide for himself. Even many of his co-worker and colleague stated that the synthesis of penicillin cannot be possible because the beta-lactam ring is highly strand and it cannot be synthesized, but he refused and rarely listened to any disappointment and continue his project, and ultimately he succeeded to synthesize penicillin in 1957. And it was these scientists, especially Shinhon, who revolutionized the chemistry or synthesis of beta-lactams. In fact, he solved one of the most baffling problem of time. Let me return a bit into the first slide. Here we have some important we talked about biological activity which is linked to a beta-lactam ring, and rest of the history and different type of the penicillin are given right over here. Thank you for watching the video.